If the idea of clean code has always felt vague or confusing, then this video is for you. When I first started coding, I didn't understand it either. This idea of adding more layers and complexities onto code in order to make it more clean seemed completely counterintuitive. After years of working on real production systems at companies like Visa, it finally clicked. So in this video, I'm going to save you years of trial and error and condense all of that knowledge into a matter of minutes. Let's dive straight into some code. Okay, so to fully understand what clean code is, we first need to understand what the issues are with code that isn't quote unquote clean. Okay, so let's look at this simple Python script we've got here. We did in a different video, which I'll link above here, which is basically how to place a trade in algorithmic trading with Alpaca. Okay, now if we look at this, the main concern we can see, firstly, is that there's lots of different stuff going on. So it breaks something called the single responsibility principle. Okay, so this script is doing so much. It's loading in environment variables. It's getting us some data on our account. It's looking at what our profit for the day was, and we're doing all of this stuff. Okay, so firstly, we want to separate that out, right? Like our trading logic definitely wants to be separate from the logic that loads in environment variables. Okay, because then we're going to have a clear separation of concerns. And if we want to, in the future, let's say, for example, change the name of one of the environment variables, that shouldn't affect the trading code. And this should all still be able to carry on as usual. Okay, let's look at some other things that are going on. So if we look at the account that we're declaring, so we're creating this entity or this object called count based on the get account method that comes from account. So if we look here, this is returning an Alpaca model called a trade account. Right now, initially, just throw this quick script, that's obviously fine. But what if in the future we want to change the provider and move, let's say, to interactive brokers? Well, they're going to return a different type of object. So that means that all of the code is going to have to change. Whereas in clean code, we would have our own account object, our own data class, and we would actually map the Alpaca trading class onto it. Now, why is that? The reason is because then what we'll have is some core logic that remains the same forever and never changes. So let's have a look at how we can actually move this into a more cleaner variation of it so that it's 1, maintainable, and 2, scalable, and thirdly, testable. If we look here, I've created a folder called clean, okay? And what we normally do is we start in the domain layer, okay? So if we start in the domain layer, we can think about what are our quote unquote real world objects? What are the things that we're going to actually deal with? And these will become our entities, right? So we know in an algorithmic trading project, we're always going to want an account that has some sort of data, right? And usually there'll be a lot more in here. Like, for example, we'd probably have like a UID, which is a string. We'd probably have, for example, like we'd want to know actually what our balance is, which would probably be a float. So there's lots of different things that we can add onto this, right? And this will live forever, okay? Because these are just standard data types that we put in that come with Python, and we created our own data class. So this will live forever, and we can use this for a number of different brokers. Okay. We obviously want a trade object. So when we're placing a trade, we need some sort of object here. So get rid of this. We want some sort of trade, which will take a symbol and a quantity, right? Just seems super simple for now. Okay. We then might also want an order receipt. Okay. So to confirm that trade's gone through, to have some sort of ability to acknowledge that for reconciliation or whatever it might be. Okay. So there are 3 simple models that we want. The second thing that we then do, so obviously, again, just to reiterate the benefits of that, is that these will live forever. So no matter how long this project lasts, we can keep building on top of this, okay? And that means you don't have to swap different pieces of code in and out. The second thing we usually do when trying to follow clean architecture is we think about like, what are the real world use cases? What are things that we actually want to do? If we come in here, we can look at this and we can say, okay, we want to get an account. At some point in an algorithmic trading project, we're going to want to understand what the account balance looks like. Okay. We might want to confirm the asset exists. So is this asset definitely tradable? Is this broker going to supply us the ability to do this? And also to submit an order, right? We're going to want to submit an order. Now, what we've actually done here is we've created an abstract class. Okay. So what is the benefit of this? Well, the benefit of this is that this code, again, can just live forever. The idea is this should never really have to be changed. I mean, you can obviously slightly alter it, but the idea is that you don't want any of this code to depend on the infrastructure layer. So the actual data layer, the connecting to actual brokers. And the reason is because then instead of having to change your code, you can just write new code and layer this on top. For algorithm trading, this is especially important because your strategies aren't always going to work. You might have one strategy that on its own just does nothing. But then when paired up with a second strategy and combined together, does something really well. Okay. In the world of algorithm trading and quantitative finance, you don't just create stuff and it doesn't work and throw it away. These are long-lived projects that you want to hold, ideally for at least 10 to 20 years, but, if lucky, for the rest of your life, or if well maintained, I should say. Okay. The second thing to note about this is we're only really importing stuff from the domain layer. Obviously, this ABC just comes with Python and allows us to create abstract classes. But other than that, we're only looking at the domain layer. So we're using these entities we've created, which are just our data classes. So the account and the order receipt that for us are going to live forever. Okay, these things won't change. Whereas if we'd have used the Alpaca account, that means when we go to import interactive brokers, we'd have had to completely rewrite all of this code. And our core business logic would have had to change. So this is how we do this. And what this allows us to do is then start implementing an interface of this. Okay. So this is like an abstraction layer. That means that the load of the code doesn't really become concerned with this. And what we can do is if we look at our infrastructure layer, we can create an Alpaca specific broker, which inherits from iBroker, which is our abstract class. And all this means is that we're going to try and make sure that it follows the rules outlined in this iBroker. Okay. So in here we say, okay, we need to be able to get an account and it has to return our version of an account. Okay. So we can always use it. So we look in here, we see get an account and it gets an Alpaca account and then it just maps it onto here. Okay. Now, if we wanted to be super strict with following clean architecture, we should create a mapper here, which is just an extra method to do this mapping. But just for the sake of this tutorial, let's just add them in here. So for our equity, we'll just take in Alpaca's equity and the last equity we can get there and the buying power. Okay. And what this means is, let's say interactive brokers have different names for these. This might be, for example, called current equity. We can again just map it straight onto this. Right? And there'll be no issue. Confirm asset exists. Same thing. Got to return a bool. We look here. You can see here, it returns a boolean. Okay. And the same thing for this. Submit a market buy order. Okay. The DAF is perfect. Now, all we're missing now is basically an application layer. Okay. And all this is going to be our controllers, or the way that we actually say to this code, start running. Okay. So we can just set up a simple class that talks to iBroker. Okay. So we're abstracting the details away. We're just going to do all of this stuff that we want to do. So we're going to say get account. And all it's going to do is return the account, do some printing there. Same thing for executing a trade. Okay. Now, by contrast, if this actually spoke to Alpaca broker, then we'd never be able to swap this in and out. And then if we look at our main function and we look at main clean, we can see how much cleaner this is. So if we get the original file and we open it to the side, click these folders, look at all of this. So all of this loading of environment variables is abstracted away into just this. So immediately we can see there, it looks a lot cleaner. It's a lot easier to read. We can see what's going on there. The initialization of the client has been completely abstracted away. So if we look actually into the Alpaca broker and we come here, we can actually see that in the initialization of this class, we're able to create a trading client. Okay. So again, this is one of the ways in which the code is apparently cleaner, right? We then use our controller or our application layer to actually start doing this trading logic, get our account. And this time the account is our own account, right? You can see here, this is just our own data class that we created. This is not one of the data classes that was created by Alpaca. We can then place a trade, a lock symbol. If we look at this, so the trade object here versus all of this code, these things like order side, these enums, like time and force, these are all very specific to Alpaca, which we now abstracted away from our code. Okay. So the idea is that this kind of reads a bit cleaner and we abstract away all these unnecessary details that our core business logic doesn't need to know about. And that means that it's a lot more maintainable because you don't have to keep changing every single piece of code. We just change the implementation details, i.e. that domain layer, those abstractions we wrote, they stay the exact same. So that's a brief overview or condensed the knowledge into just a matter of minutes. If you enjoyed watching this, I think you'd really enjoy the original video of where we built this trading algorithm to produce the logic. And it's important to note that there is a time and a place for this, and it will make sense once you watch that video. This is for more long-term projects that we want to exist for a long time, whereas this sort of messy, just get the code working, definitely has a time and a place, although that is just when you want to really quickly hack together a proof of concept. If you're looking to build maintainable systems that will last for a long time, that's something that's crucial in algorithmic trading. You need to start looking at more cleaner code.